Hello viewers, in today's class we are going to discuss one important problem from integrals, right? And in this class we are going to discuss this integral which is 0 to infinity, and the integrand is 1 over x raised to 4 plus 1, and we can solve this integral by the method of contour integration, right? So we can also apply the method of residues to solve this integral, but here we'll make use of the concept of beta and gamma functions, right? So let us start. So let us first take this integral as I, right? So here what we will do, we'll take help of the method of substitution, and we'll take x raised to 4 equal to t, right? So here we'll uh, introduce a variable t such that x raised to 4 is equal to t, right? So x can be written as t raised to 1 by 4, and let us differentiate x with respect to t, right? So we have to find the derivative of t raised to 1 by 4 with respect to t, that is 1 over 4 t raised to 1 over 4 minus 1. So here we'll make use of the power rule for differentiation. So this is 1 over 4 t raised to 1 minus 4, that is minus 3 over 4, right? So now dx can be written as 1 over 4 t raised to minus 3 by 4, and here we have dt, right? Okay, now see here the limits of integration vary from 0 to infinity. So when x is 0, then obviously t is also equal to 0, and when x tends to infinity, then the value of t also go to infinity, right? So now we can write this integral in terms of t. So we can write I as 0 to infinity. Here we have t is equal to 0 to infinity, and here we have dx. For dx we can write 1 by 4 t raised to minus 3 by 4 dt, and in the denominator we have t plus 1, right? So let us rearrange the terms. So we can write 1 by 4 outside the integral. We have 0 to infinity. Here we have t raised to minus 3 by 4, and here we have 1 plus t, right? Okay, now see, here we have this integral. Now let us revisit the definition of beta function in terms of integral. So beta mn is defined by this integral, that is 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx, right? So now this integral is similar to this one, and here I will express this integral like this, right? So for this what we will do, see here we have 1 plus t raised to 1, right? And here we have t raised to minus 3 by 4. So let us compare these two integrals to get the values of m and n. So m minus 1 can be taken as minus 3 by 4. So m is minus 3 by 4 plus 1, that is minus 3 plus 4 over 4, that is 1 over 4, right? And m plus n may be taken as equal to 1, right? So m is already 1 over 4, so n is 1 minus m. So we have 1 minus 1 by 4, that is 4 minus 1 over 4, that is 1, that is 3 over 4, right? So the value of m is 1 by 4, the value of n is 3 by 4. So now we can represent this integral I in terms of the beta function. So we have here 1 by 4. This is 1 by 4, 0 to infinity. And we have t raised to minus 3 by 4, right? So here t raised to minus 3 by 4 can be written as m minus 1, and m is 1 by 4, so we can write 1 by 4 minus 1, so that we can get this term x raised to m minus 1, right? And here we have dt, and 1 plus t raised to 1. So we have 1 plus t raised to 1. 1 is equal to m plus n. M is 1 by 4. N is 3 by 4, right? So this is 3 plus 1, 4. 4 over 4 is 1. And 1 by 4 minus 1 is minus 3 by 4. So again we'll get the same integral, except that we have expressed the integrand like this, right? So now I is equal to 1 by 4 beta of mn. M is 1 by 4, n is 3 by 4, right? So now we have to find the value of beta 1 by 4 comma 3 by 4, and we know the relation between beta function and gamma function, that is beta mn is equal to gamma of m gamma of n divided by gamma of m plus n, right? So here we have 1 by 4, gamma of 1 by 4, gamma of 3 by 4 divided by gamma of 1 by 4 plus 3 by 4, right? So this is 1 by 4, and we have here gamma of 1 by 4. And now see, here we can write 3 by 4 as 1 minus 1 by 4, right? Why we are writing gamma 1 by 4, gamma 3 by 4 like this? Because now this term is similar to the term which appears in the Euler's reflection formula, right? So now we have here in the denominator gamma of 3 plus 1 4, 4 over 4 is 1, so gamma of 1. So now the Euler's reflection formula, it reads like this, that is gamma of n, gamma of 1 minus n is equal to pi over sine n pi, right? And now see, if we take this n as 1 by 4, then we have this term, that is gamma of 1 by 4, 1 minus 1 over 4. So taking n is equal to 1 by 4, in this term we have pi over sine pi by 4, right? So this is pi, sine pi by 4 is 1 over root 2, and this is sine 45 degrees, so this is pi root 2, right? So now this term is equal to pi root 2, right? So we have I is equal to 1 over 4, and here we have pi root 2, and gamma of 1 is equal to 1, right? Because we know that gamma of 1 is equal to 1, right? So the value of this integral I is given by pi root 2 divided by 4, right? So if we rationalize the numerator and denominator by square root of 2, then we can also express it like this. We have pi root 2 over 4 multiplied root 2 over root 2. So this is root 2 times root 2 is 2. So we have 2 pi over 4 root 2. So this is 2 to the 4. So we have pi over 2 root 2, right? So viewers, the value of this integral is equal to pi over 2 times root 2.